Hello everyone, my name is Siti Adriana and I am a postgraduate student from Universiti Teknologi Malaysia Alam. Today, I will be presenting my research entitled The Enhancement of Mortar Performance by Utilizing POFA and GFRP as a partially replacement of sand and cement. This will be the overview of my presentation, starting with the introduction, problem statement, objective, literature review, methodology, results and discussion, and lastly, conclusion. The first one is the introduction. This study is about the utilization of waste materials to produce high-performance mortar. In this study, the design mortar need to achieve the targeted strength, which is 30 megapascal. In order to achieve the targeted strength of the mortar, what will be done is POFA will be used as a partially sand replacement, while waste from GFRP will be used as a partially cement replacement. The main reason why POFA and GFRP need to be incorporated in mortar is because both types of waste materials able to produce high-strength mortar, promote low cost in construction industry, and have a better control of waste management. So, what is POFA? POFA is known as palm oil fuel ash and it is obtained from United Palm Oil Mill Nibong Tebal Pulau Pinang in the form of ash when the fiber, shell and the mesocarp are burned at high temperature. Next is GFRP, which is known as glass fiber reinforced polymer and it is obtained from CRT manufacturing Shah Alam in the form of powder that was produced during the manufacturing of the GFRP rebars. For the next part, I will be explaining on the problem statement of the study. As you can see in the slides, there are two current issues regarding the natural sources, which are sand and also cement. To conclude, these issues need to be solved by minimizing the usage of the sources by replacing with waste materials. As we all know, sand and cement are important materials in the production of mortar and concrete, and the demands for these materials are increasing due to the growing development in Malaysia. It is reported by Department of Minerals and Geosciences of Malaysia that the sand mining operation has risen from 24,471 to 34,341 million tons in Malaysia. Besides, due to high demand of cement production, it will threaten the environment. Thus, a solution had been proposed by replacing POFA and GFRP in mortar. As mentioned by Hashim et al. 2019, POFA can be used as alternative materials because it has same characteristics with sand. And it also reported by Wan Ahmad et al. 2020, the application of POFA, which is finer than natural sand, helps to improve the internal structure by filling the existing void. For GFRP, Farinha et al. 2019 had stated that waste from GFRP can be implemented as a partially or fully replacement in concrete or mortar, and binder effects that comes from waste from GFRP can act as a pozzolanic characteristics that able to enhance the strength of specimen. Next, we will look into the objective part. The objective of this study is to determine the effect of POFA and GFRP in mortar as a replacement ranging between 0% and 10% towards compressive strength at 3, 7, and 28 days. Moving on to the next part, which is literature review. For the first paper with the title of Utilization of Palm Oil Fuel Ash as an Replacement for Fresh and Hardened Concrete by using Powder and Liquidation Method, it can be concluded that 10% POFA incorporated in concrete shows the highest strength. Next, the finding on the properties of concrete containing ground palm oil fuel ash as fine aggregate replacement had shown the same percentage with the previous paper, which is 10% POFA is the best amount to be used as a partially sand replacement in concrete. For GFRP, it was reported in the assessment of glass fiber reinforced polymer waste reused as filler in mortars, mechanical of mortars with GFRP showed an improvement. Now, we will look into the methodology of this study. The first step is the sample preparation and continue with the microstructural analysis, which are scanning electron microscope, SEM, and X-ray fluorescence, XRF, on the raw materials. Next, the assessment on the compression test will be done in order to determine the optimum percentage for each mixture. Lastly, the collection and analysis of data will be done. Next, this is the mixed proportion of mortar cubes for this study. I will be expanding on the results and discussion. The first part is on the SEM on waste materials. As can be seen on the slides, raw POFA and GFRP had an irregular shape compared to POFA that has rounded and angular shape. Next, raw POFA and POFA had rough surfaces due to calcium elements, while GFRP showed smooth surfaces that is due to the presence of silica elements. Next, for the XRF of the waste materials, POFA recorded the highest percentage of calcium oxide with 36%, while GFRP recorded silica oxide as the highest percentage with 53%. To sum up, POFA in this study can be classified as calcium activation agent, while GFRP can be classified as silica activation agent. For EDX mapping analysis, it can be seen that the most concentrated element in POFA is calcium element that had been proven from the XRF results. The texture can be classified as uneven surfaces and have some indentations that called as island. Due to that, it will result in low mechanical properties as the requirement of water will be high as the amount of POFA increase in the mixture. Next, for EDX mapping analysis on GFRP, it can be seen that the most concentrated element is silica. Silica is one of the main materials in cement. Thus, it can conclude that waste from GFRP can be used as a cement replacement. The silica texture is smooth that promotes bonding element between the piece and aggregate. For the first mixture, which incorporating POFA as a partially sand replacement in mortar, it can be remarked that 7.5% is the optimum strength with 23.41 megapascal compared to control specimen. And the possible effect that make that particular 7.5% is the optimum comes from a good filler effect that has the ability to fill in between voids. Next, for the second mixture, which incorporating GFRP as a partially cement replacement in mortar, it can be remarked that 5% is the optimum strength with 23.74 megapascal compared to control specimen. And it can be concluded that the presence of waste from GFRP able to enhance the strength of mortar. For the last mixture, which is a combination of optimum percentage of POFA as a partially sand replacement, which is 7.5%, with optimum percentage of GFRP as a partially cement replacement that was recorded at 5%, it showed the highest result on compressive strength with 39.38 megapascal compared to control mortar with 51.1% increment. The enhancement of the mixtures was due to the microfilling ability of the POFA as it can produce more denser of particles due to high fineness. Due to the pozzolanic reactivity that was boosted by the silica elements created by waste from GFRP, the dual effect that occurred from the optimum percentage of POFA and waste from GFRP can be considered as an improvement to the strength of mortar. For the last part is the conclusion for this study. Nowadays, natural resources have reached a worrying situation as there will be shortcomings for future generations. Moreover, it also worries the environment in which pollution will occur during the process of sand consuming and cement manufacturing. Due to that, an engineering alternative needs to be explored in order to reduce the usage of sand and cement. Thus, this study had incorporated the unwanted waste materials that were landfill and no proper waste management to eliminate the waste which are POFA and waste from GFRP. The effect of dual action that comes from POFA and GFRP as a partially sand and cement replacement, able to improve the performance of mortar and produce a low-cost production and promotes to green construction in future.